Hi, in the previous video, we had finished the part 1, that is the manual calculation of all the cost and path matrices for from k equal to 1 to 5, because we had taken an example for 5 nodes. So in this video, we'll discuss on the coding part of the Dijkstra's algorithm in Dev C++. Okay, so I'll just share Dev C++. Okay, so let's start quickly. So this is the header file, as you all know, which is used because we have to include the printf and scanf statements. So for that, we need this header file, stdio.h. Next is conio.h. We're going to use a function called getch, get character. So for that, we have included this header file, conio.h. Okay. So as and when we use different statements and functions, you can decide on which header files have to be used. Okay. Now this is a global declaration for path metrics. So P is the variable which we have used for path metrics. Okay. So I'll just quickly explain one thing. So I've been telling in class about, yeah. So suppose we have a main function. Okay. Main function. Okay, and then we have ended this. We have written few things and we have ended the main function. So suppose we call a path function. So there's a function called path of ij, and then we have called this function here. Okay. Now when you call such a function, what you have to do is you have to declare it earlier, right? So you have to do we have to write void path int I, right? Int j, like this. Okay. With a semicolon. So this is the declaration of the path, and then which you have used here, and then you can you can start defining the path function here, right? Like this. So suppose you are using a variable p of I j here, something like this. Okay, k equal. Okay. Now this variable, suppose you are also using here. Suppose you are also using that variable in main function. Okay. So now, so for that, if you're using a variable in main function as well as path function, what you have to do is you have to declare it again globally. Okay, so you have to declare it globally, fine? Because otherwise, this path function will not know what is p. Understood? So you have to, otherwise you have to like declare it separately. Understood? So like this. Okay. Suppose you have declared it globally, you can use it in both main function and path function. Okay, so this is one way. Now suppose you want to include this function here. So in this case, you don't need this line. Okay, you can directly include it above main function, end the function, and then start the main function. Okay, but when you're using this here, you have to declare this path function prior to main function, like this. If you don't put this path function, or you can put it inside the main function also, like this also, no problem. Okay, if you don't include this line like this, you can't define the function after main function. You should have defined it above main function. In that case, you don't need this line anywhere because it is already above the main function. Okay, so these are the various ways. Okay, fine. Now go up. Yeah, so here we have declared the path matrix P of 10, 10 because our node numbers are 5. So we have given anything above 5. So 10 is fine. Okay. So yeah, so P is the path matrix variable which we have used here. It's a two-dimensional matrix, right? It is two-dimensional array, right? So it is P of 10, 10, ij, like that. Now the main function starts, and then you can see the main function is ending here, and then we have started the path function. So for that, we have included a line here to declare the path function, void path int I int j. You can put this above here also, no problem. Okay. So now let's start the main function. So in that we have ijk. Ijk we know, right? So it's destination via path. And then n is the number of nodes. N is the variable which we are going to use for getting the number of nodes. Okay. Next is cost matrix M of 10, 10. M is the variable which we are going to use for cost matrix. Okay. So 10 because our node number is 5. So we have given just higher than 5. Okay. So M of 10, 10 is 5. And then the path function declaration. Now let us start with accepting the number of nodes. Okay. So to accept the number of nodes, input the number. So /n is to enter start from the fresh line. Okay. So enter the number of nodes, will print it. So where are you going to accept the value of nodes? N. So scanf %d ampersand n. Now in scanf you should never include /n or /t. It will give you an error. Okay. So just %d because n is integer. Ampersand n. This will ask the user to enter the number of nodes. You have to print 5. Okay. And then we have to, so the starting is to accept the number of nodes from the user and then accept the cost matrix from the user. So unless you enter the cost matrix, this tool will not know what is compiling, how to compile, right? So what is the cost matrix? What is the node diagram? That will be obtained only when you enter the initial cost matrix. So we have just printed enter the node connection matrix. You can print enter cost matrix. Now to indicate the direct connection between two nodes, enter the weight as 100. That however you want, you can print. And then we have given /2/n so that it jumps to 2 new lines. And now you have to start printing the initial cost matrix. So how to start printing the cost matrix? First, you have to print the column numbers and row numbers, right? So first you have to print the column numbers and then come to printing row numbers one by one. So first we have just used a loop variable I, which is moving from 1 to 5, right? N is 5 now. And then how did you, so you have to start with a space, and then you have to start entering 1, and then 2, 3, 4, and then 5 with 1 tab space between them. So it will start from 1. 1 will be printed after a tab like this, right? And then %d, so 1 will be printed. Then the next loop, so first tab, so this tab, and then %d, that is I equal to 2 will be printed, then a tab, 3 will be printed, and so on. Okay? So this is to print the column numbers. So now let us see how are we getting this in the output screen. Okay. Yeah, so this is the output screen. Okay. So enter the number of nodes. So what should we enter here? 5. See this, whatever we had given there. Enter the node connection matrix to indicate no connection. Enter the weight as 100. And then see this, after a tab, the column numbers are printed 1 with a tab, 2 tab, 3 tab, and so on. So after the end of 5, you have to jump to the next line and start printing the row numbers here. Okay. So now let us go and see the code. Yeah. So like this, column numbers will be printed. Now to print the row number again, we have started a new loop. So I from 1 to n, and then print that I one by one. So not after a tab, right? It is starting from a fresh line, and then directly 1 will be printed, and then a tab will be printed, will be given. Okay, and then it will jump to the next location. So now the column numbers will become j, and I will become the row number, correct? And then what are you going to scan? So you are going to accept the cost matrix in which variable? M, right? So ampersand M of ij. So for that corresponding ij, you're going to enter the cost matrix. So again, M is integer, right? Here, so %d. And simultaneously, you can initialize the path matrix also to all zeros. So P of ij is equal to 0. Clear? Because the initial path matrix is 0, right? So for all the combinations of I and j, the path matrix will be initialized to 0 within the same loop itself. Okay. So this much of the code, what is done? You have accepted the cost matrix from the user and then initialize the path matrix. Okay. So we'll quickly go to the algorithm and then we'll go to the output window. The next is Dijkstra's algorithm code. Okay, now we know I is the source node, J is the destination node, and K is the via node. So first job is to initialize the diagonal elements to zeros. So So for that, take any loop variable. You can take I, j, anything, because it is not here. I doesn't mean that it is source node. Okay, you can take any loop variable like p. Sorry, p is variable is already used. I'll take z for z equal to 1, z equal less than or equal to this, and z plus plus m of z z is equal to 0. Only thing is you should have, so you should put int, okay, or you can put it here also, comma z, fine, like that you can put, no problem. So this doesn't have to be any of these, understood? So you can use any loop variable because you're just making the diagonal element 0. So if you put the same variable here, it is going to be the diagonal elements only. So for 1 to 5, that m of z is going to be 0. So diagonal elements are becoming 0. Now this is the loop which I was discussing in the during explanation of PPT. So k equal to 1 is the main loop, because k. So what we did is we first we did for k equal to 1. In that k equal to 1, we traversed for all the combinations of I and j. So 1, 1, 1, 1, 2, 1, 3. I equal to 1, j equal to 1 to 5. Then I equal to 2, j equal to 1 to 5, I equal to 3, like that. And then k will switch to 2, like that. Okay, so in the PPT, after the initial cost metrics, where was the first change happening? It was actually from 2 to 4, right? Because 2 to 4 had no direct path. The initial cost metrics value was 100. So let us see that particular example. So that is when k is becoming 1, and then I has switched to 2, and then j has become 4. Okay, so the m of ij value is now 100. So if you take the sum m of ik, that is 2, 1 plus 1, 4. So 2, 1 is 3 plus 2, right? 5. If you see the example, see the node diagram. So that is 5. So if 5 is less than 100, right? If this sum is less than 100, that is the previous value. Replace what? Replace the new m of 2, 4 with 5. That is m of 2, 1 plus 1, 4. Okay, so update the cost matrix value of m of 2, 4 with 5, correct? And simultaneously change what? The corresponding path matrix. So path matrix, that is P of 2, 4. Here I is 2 and J is 4, right? P of 2, 4 will now become what? K. What is the K value? 1. Correct? So simultaneously update the path matrix value to K equal to 1. So this will happen wherever there is a change. So at the end of this loop, what is done? Our coding is done. Okay, so here we are accepting the cost and initializing the path matrix. Here we have done the algorithm, and now we are just printing the final cost. Where is the final cost matrix available? M of ij. Path matrix is available in P of ij after this bracket, right? Okay, so here we are just printing the final cost matrix. So you have to use the same way. You have to print the column numbers first, okay? And then you have to print row number 1 by 1, and then you have to print M with proper tabs, okay? If you don't put these tabs, it is not going to come properly. And then copy paste these same lines and then print it here and paste it here and then change it to P, where you're printing the final path matrix, okay? So till this, let us see in the output window. So here now we have to start entering the cost matrix values. Okay, so let me see what was the initial cost matrix value. So 0, 2, 10. So I'm entering after a tab. Okay, so here, okay, 3, 20. The only problem is if you make any errors in this entering, you have to again run it again. Okay, so that's only difficulty. So 2, 0, 3, 100, 100, 10, 3, 0, 100, 4. So this is a symmetric matrix. You can see for 4, this will be 300, 100 like this. Right? So 300, 100, 4 to 4 is 0, 4 to 5 is 1. Then enter. 20, 100, sorry. Now, yeah, one more thing is you can change if it is in the same row. You can't change the previous rows because it is already traversed that loop, right? It will not go back to the previous loop. So current row can be changed. So 20, 100, 4, 1, 0, 0. Okay. So enter. So what did we do? So after accepting the cost matrix, the path matrix would be initialized by now. Not by now, once I put enter. Okay. To all zeros, and then after the algorithm is ending, Dijkstra's algorithm is entering, we have printed the final cost and path matrix. So when I enter, the final cost and path matrix should be printed. See this? The final cost matrix and the final path matrix. So you can cross check this with the values which you had obtained in manual metrics which you had written. Okay, so for k equal to 5, it would be the same thing, 0, 2, 10, 3, 20. It would be, yeah, 0. So what is the final? 0, 2, 5, 3, 4. Yeah, 2, 0, 3, 5, 6. Correct. So path matrix is 0, 0, 2, 0, 4. Yeah, fine. So this much is done. Clear? So now let us go back to the code. So now, okay, let me show this here itself. So next is enter the source and destination. So when I press 2, so what example did we take? 2 and 4. So if I press 2, source first and then destination. Okay, so here now 2 is going to be I, 4 is going to be J. I'll tell you why space is used. It is because in the code we have it like that. Okay, so 2, 4. Okay, so now when I'm pressing enter, the weight is 5. Okay, so the weight is 5. How is it 5? So just check this final cost matrix, 2 to 4. So this is 5. Okay, so weight is 5 is put here. So that is from M of I. And the path is, let's see this, 2 to 4. So what is this? 2 to 4 here, you see via path is 1. So 2, 1, 4, like that. To repeat, press R. So because you don't want to enter this cost matrix again and again, right? So we have put this one do while loop where you want to execute these same things again. So when I press small r, I will get the source and destination nodes again. Now I'm typing 2, 5, okay? So 2, 5 here, you can see the weight is 6 and 2, 5 via path is 4. See this. So weight is 6, fine. So that is from M of ij. Now the path is 2, 1, 4, 5. So how do we get that? So 2 to 4, 2 to 5 is 4, right? Now you have to check 2 to 4. What is 2 to 4? 1. See this? Then you have to take 2 to 1. So it is 0. So 2 to 1 will be printed first. Then 1 to 4 will be printed first and then 4 to 5. So let us see how this is printed, okay? Now let me go back to our coding. Now, so see this. So do while. So do while loop is there. Okay. So do these many things while you press what? While you press an R. So this should be within single quotes. Okay. Now, so if you don't put in single quotes, it will not work. Okay, because it's a character, right? So you have to put it within single quotes. So get ch double equal to R. So while you press R, these things will be again executed. Okay, so see this. Enter the source and destination node. So that's what you saw in the output window. How are you scanning it? Percentage D space percentage D. So what is the first thing? I. So if you press 2 first, I will be 2 and then J will be 4. Yeah. So let us take the example of 2, 5 because that is more complicated, right? 2, 4 is easier. I'll just explain 2, 5. You understand 2, 5, 2, 4 is easy. Then print weight is. So weight is will be printed and what from where? M of ij. So cost is, or you can print cost is, okay? So M of ij is the matrix which has this weight. Okay, so M of ij print. So M of 2, 5 will be printed here from the M matrix. Next is path is. So path is will be printed and then print f. So what is printed first? 2 and then one arrow is printed, correct? So you wanted to print 2, 1 and then 4 and then 5, correct, like this. So in this printf statement, what will be printed? What is I? 2. So only this much will be printed. So these many things you still have to print, understood? So this much will be printed. Now call the function path of ij. So we are calling the function path of ij where I is 2 and now, as of now, we have entered 2, 5. So I is 2 and j is 5. So we are basically calling path of 2, 5. So it will jump to the place where we have defined the path. So for your understanding, I've put every call properly here. Okay. So let us see it. So now it is going to call what? The first thing is it is going to call path of 2, 5. And then let us see what happens. So we have declared this int k here. Now what is k? K is p of ij. Correct? No? K is the via path p of ij in the path matrix. So now p of 2, 5 will be extracted and then k will be assigned as 4, the first step. So now the value of k is 4. So if k is not equal to 0, 4 is not equal to 0, correct? So it will go back and call again. So we have again path function call inside the function. Okay, so this is recursive. So p of I k it is. So what will it see? So once you see p of 2, 5 and it is non-zero, you have to check again p of 2, 4, correct? No? So does it have a direct? Unless it has the direct path, you can't print, correct? So p of 2, 4, because k is the updated value of k is 4, so it will see p of 2, 4. So that's the second one. So once it calls the function again, it will go back to function call. So now this will become p path of 2, 4. Okay. So path of 2, 4 will be called again, and then it will check what is k. So what is k now? P of 2, 4. What is p of 2, 4 from p matrix? You can see it is 1 in the final path matrix. It is p of 2, 4 is 1. Okay, now is k not equal to 0? Yes, 1. 1 is not equal to 0. So again it will come here. Now what is the k value now? 1. So it will call path of 2, 1. See this? Path of 2, 1. Okay. So path of 2, 1 will be called. Okay. So when it is called again, it will come back to this. So I put here path of 2, 1. Okay. So now it will come here. So what is path of 2? P of 2, 1 now. P of 2, 1 is 0. Good. So that means 2 and 1 have a direct path between them. So 0. So it will not go back to this. This is not satisfied, right? K is not now 0. Only if it is not equal to 0, it will go to this function. So when did you call this? From where did you call this to 1? Here, right? So it will come back to the place where it is called. Then it will go to the next line. So what is the next line? Just print that k value. It will print k value here. What is k? 1. So 1 and then 1 arrow. So this much will be print. Clear? This is how so when k equal to 0, that value will be printed. Whenever that k value is becoming 0, that particular k will be printed. Clear? Now that is done. So it will come to next line. What is next line? This is not over, right? You have to still check the other way. Now what is the k value? 1. And what is j value? 5. So you have to check 1 and 5 also. So it will call again 1 and path of 1, 5. So it will come here. So next is path of 1, 5. Okay, so the fourth part. And then what is path of 1, 5? From the matrix, P matrix, path matrix, it is 4. Now again the value of k becomes 4. So is 4 not equal to 0? Yes. So this will be satisfied. It will again call the path function. So when you call this path function, it is again calling this path function. So it will call, what is it? What is the new k value? 4. So what will this become? This path function become 1, 4, right? So it will become path of 1, 4. Okay. So again, it will go back to path function call. So again, the last one is path of 1, 4. Okay. So not last one, path of 1, 4. It will check what is the k value for 1, 4. What is the k value for 1, 4? It is 0. So once it is 0, it will not go to this part. So where did you call 1, 4 from? Here, correct? Here it was. Now what will it print? It will print 4 and then arrow. So when the k value becomes 0, that will be printed. So it will print 4 and then arrow. So this is also done. Clear? So since this is done, it will go to next line. Okay. So now here, what is the latest k value? 4, right? 4 and then j is 5. So 4, 5 will be called. So it will again go to this path function. So path of 4, 5. Okay. So what is the k value? So here. So what is the k value for 4, 5? P of 4, 5 is 0. Clear? So where did you call this from? So 0. So it will not go back to this. Where did you call this 4, 5 from? Here. Correct. So done. Do you have anything after this? Nothing. So where will it go back? It will go back to the place where the main function was called. And then finally, what will it print? 5 will be printed. Clear? So 2 is printed here, 1 is printed here, 4 is printed here, and then 5 is printed after that here. So this is how the output is printed. Clear? Now to repeat the process, press R. That is printed. If you don't print this, how will the user know what to print, right? Whatever you put here, if I put capital R here, you have to put capital R here. Understood? You can press anything. You can put X here, then you should put X here. Sorry, small x. Understood? It's your wish. Clear? So that is about Dijkstra's algorithm. Okay. So if you have, I think this is pretty much clear because I've put all the calls separately and I've put the numbers also separately. See this? So this is 1, 2, 3, 4, 5, 6. So I have also put, so one is called here and then second one is called from here. Third one is called from here. Fourth one is called from here. Fifth one is called from here. Sixth one is called from here. Okay, so accordingly I put the numbers also. I hope this is clear. So go through this again and again. If you have doubts, I think if you watch it again, you'll your doubts will be clear. Okay, fine. So go through all these because this will improve your coding skills. Okay, C coding is very much required as your base. Okay, so and try to do this coding by yourself. So understand the coding and then try to type it by yourself. Unless you type it by yourself, nothing is going to work out. Okay, thank you. So any doubts you can ask later. Okay, okay, thank you then.